is the hardest topic that you learned this semester because of all the new vocabulary and because of the length of the unit. There's a lot of things that we did in here. At any point, if you want to take pictures of these slides instead of writing stuff down, you're welcome to do that. I don't care. So the topics that you learned about in chemistry, just some basic chemistry definitions. You talked about things about atoms, protons, neutrons, and electrons. You talked about molecules, elements, just some basic definitions, things that you'll continue doing next year in chemistry. Then we looked at the types of bonds, which I'll go through in a second, properties of water, and I know if you were in Mrs. Contress's class, we'll go over some of those to help you remember some of them. Enzyme action, biochemistry, which is carbs, proteins, lipids, and nucleic acids, and then that's the same as organic molecules, so I don't know why I wrote that twice. So, here's the questions that I'm going to answer, and I'm going to talk fast, and I'm going to get through as much as I possibly can. If you want to ask me a question, feel free. I will stop if there's something that you're not sure about. So the first two questions that I have here, I'll just put the answers here. What are the elements found in living things? Second?
Yeah.
All right, so in my class, we talk about something called the sponge elements. I'm not sure if you're in another class if you talk about them, but these are the main elements found in living things. Sulfur, phosphorus, oxygen, nitrogen, carbon, and hydrogen. Sometimes you may see that as an acronym CHOMPS. I just use the word sponge. These three right here are the most important elements found in living things. Carbon especially. That should be, I'm kidding. Hold on. I already messed up, giving you wrong information here. Okay. Oxygen, carbon, and hydrogen are the three most important elements found in living things. Primarily carbon is called the element of life. Carbon has some amazing properties. It can form bonds with up to 4 other things. It can make a diverse amount of new compounds. They can be big, they can be small. Every single living thing is a carbon-based organism. So carbon is the element of life. There would be no life without carbon. So with that being said, we also talked about 3 main types of bonds. And those bonds were a covalent bond, an ionic bond, and then a hydrogen bond. We didn't really do too much with these in class. It's more of a chemistry thing. But covalent bonds, we said that they were strong, and it's where elements share electrons. I'm going to abbreviate that with an E and a negative sign. Okay, so covalent bonds are good for building life because they are nice and strong. We don't want life to fall apart. We want it to be strong. Ionic bonds, we said that they weren't as strong, and this is where electrons get taken from one element to another. And that ends up giving us positive and negative charges. You might have learned about table salt, sodium chloride being formed that way. Hydrogen bond is one that we spent a little bit more time talking about. And a hydrogen bond, we said, was a very weak bond. But it's important because it forms water. And water is essential for life. So we actually talked about hydrogen bonds in a couple different places in class. So there are the 3 bonds that we really talked about in class, and then later on in DNA we talked about a peptide bond. All right, so now that we're talking about water, let's look at some of these amazing properties of water. So the first 2 that I have up there, polarity and hydrogen bonding, they are the 2 fundamental properties of water that give it its amazing ability. So if you remember when you learned about water, we said that it's an oxygen connected to 2 hydrogens. Sometimes it's like that, sometimes it's like this. We said it's kind of like a Mickey Mouse molecule. Okay? So it's 2 hydrogens connected to an oxygen. Because of the way they connect and because of their elements and something called electronegativity, which you don't need to worry about, we end up having positive charges on the hydrogen atoms and negative charge on the oxygen atom. And that keeps them together. We call that polarity because it gives them 2 poles, positive end and a negative end. And this polarity of water is actually what's going to allow it to bond to other water molecules and give it all of these other amazing properties. So when I have two water molecules that want to connect, so here's another one, we're going to connect negative charge of an oxygen to the positive charge of the hydrogen, and they connect with a weak bond, which is our hydrogen bond. So hydrogen bonds allow water molecules to bond to one another. Very important property of water. Polarity and hydrogen bonding together give us these properties of water. Basically, the definition of each is really all you need to know. I'll quickly go through them. Cohesion means that water sticks to itself. Okay, so if you ever see a little water drop hanging from like a tap or a faucet, the drop gets bigger and bigger and bigger because water has the ability to stick to itself. So I use little hand signals to remember this. So clap my hands together. Cohesion, stick together. Cohesion, stick together. Adhesion means water can stick to other substances. Like glue is an adhesive, it can stick to other things. So adhesion, stick to others. Adhesion, stick to others. So water can stick to, say, your skin when you get out of the shower. Capillarity is a property of water that allows it to move upward against the force of gravity. So I put my fingers like this, and I say capillarity, moving upward. Okay, plants do, stop laughing at me. Plants do this. When the rain comes down from the ground, goes into the soil, water is able to move through the soil to the roots of the plant, to the stem, to the leaves, to the flowers, and so on. It can move upward. Evaporative coolant is water has the ability to hold heat and take it away from us. So anytime you sweat, that is evaporative coolant in action. So you can say evaporative coolant takes heat away. And then high thermal conductivity means that water can that heat spreads out evenly through water. So you have a big ocean or a big body of water, heat spreads throughout it evenly. And then the last one, neutral pH. We don't really do much of the pH scale, but it goes from 1 to 14. 7 is in the middle, so neutral pH has a pH of 7. It's not an acid, it's not a base. It's neutral. I know what's missing up there, Mr. Lyons. Universal solvent. Water also is called a universal solvent because it dissolves many things. Okay, like salt dissolves in water, sugar dissolves in water, and that's important because water is our foundation and lots of things need to dissolve in water. So they're the properties of water. Okay. Oh, good enzymes. All right, next one. Another important topic we talked about with biochemistry was enzymes. And enzymes are a special type of protein. We'll go through proteins in a second. And sometimes they are called catalysts. Here's the trick. On the Keystone exam, if you see the word catalyst, if there's a question and it uses catalyst but it doesn't use the term enzyme, that's fine. They do the exact same thing. An enzyme is a catalyst. Those words are interchangeable. Does anybody remember what enzymes end in? Like if you have an enzyme. Not ose, that's a sugar. It's right here. Enzyme ACE, like lactase, is an enzyme. So if there's a question on the Keystone and it has some crazy word you've never heard of before, but it mentions that it's a catalyst, that's okay. Don't worry about the crazy word. All you need to know is that it's an enzyme. What does an enzyme do? It speeds up reactions. That's their primary function. Reactions would not happen, or they would happen too slow if we did not have enzymes. So they're going to speed it up, and they do this by lowering the activation energy. And Mr. Lyons is going to draw a beautiful graph that you may see on the Keystone exam. So you see this kind of picture of a hill. That big hill is what it's like to do a reaction without an enzyme. Who wants to climb up a big hill? Not me. I want things to go faster. So I want a smaller hill, which is that dotted line, which is what it's like if you have an enzyme. You might hear the term enzyme catalyzed reaction or something fancy schmancy like that. So small hill better than big hill because it's quicker to go up a small hill than a big hill. Is there anything you want to add about that hill there, Mr. Lance? Okay. And we also talk about enzymes acting on things. We call them substrates. Where they come together is called an active site. So in class, we talked about it being kind of like a lock and key. They fit together perfectly like puzzle pieces. They are specific to one another, but they can also be denatured, which is a real fancy word for being messed up or ruined by a change in pH. Make it real acidic, you can ruin the enzyme. Add a lot of temperature, make it really, really hot, you can ruin the enzymes. Or add inhibitors or coenzymes, that can change the reaction rate too. Okay. So if you get the idea that enzymes speed things up, that's most important thing about enzymes. All right, 2 important reactions that you should know are hydrolysis reaction and dehydration synthesis. This is all about how we get things to build together to make something big, or how we take something big and make it into little things. So a dehydration synthesis is when we're going to take little building blocks, I like to think of them as Legos, and I build them together and I make something big, like a house, okay, as an analogy. If I take small things are called monomers. Mono means one. Make something big is called a polymer. I do that through this reaction called a dehydration synthesis. The word synthesis means to build, to make. If you're synthesizing something, you're making it. It's called dehydration synthesis because you're actually removing water at the same time. So you're going to lose some water over here too. I can also do the opposite. I can take something big, here's my little house, and I can knock it down into building blocks. That's called hydrolysis. Anytime you see the word lysis, it means to break. And I'm breaking by adding water. That's where the hydro part comes in. Okay, so dehydration synthesis, I'm making something big. Hydrolysis, I'm breaking down something big into smaller parts. Anytime you eat a meal and you're digesting that meal, that's hydrolysis. Okay. All right, so that leads us to the biggest part of this unit, which is the organic compounds. Knowing the difference between carbs, lipids, proteins, and nucleic acids. Yeah, definitely take a picture of this lovely information. In class, you probably made a big chart. I know you did in my class, and I think in Mrs. Contra's class, and I'm sure Mr. Lyons at some point, you guys make a chart too. In that chart, you probably compared these 4 things as far as their structure, their function, what they look like, their examples of them. So very quickly, carbohydrates, their function is to give us energy. It's quick energy. Think of things like sugar. If you eat sugar, you get an energy high, or sugar high, I mean. Or something long-term like starch gives you energy for the future. They have 2 hydrogen to every 1 oxygen. That is not a 10, that is a 1 oxygen. And sometimes we will see them, there's a picture, look like little hexagons, little glucose molecules. You might have seen that before on the Keystone exam. Sometimes you've seen where they will just give you pictures and ask you to identify them. If you see something that looks like that, it's a carb. If it's just one of those shapes, that's a monosaccharide. The best example of that is glucose. If there are 2 of those shapes connected together, that's a disaccharide, means 2 sugars. That could be something like sucrose. If there's a bunch of them connected together, that's a polysaccharide. Poly means many, so that could be something bigger like starch or cellulose or chitin or glycogen. Sugars end in ose. So anytime you see ose, that's a sugar, that's a carb. on the other hand, are usually a little bigger, sometimes a lot bigger. They function in a few different ways. They store long-term energy for us. They help keep us warm. We call that insulation. They help protect us from injury, give cushioning to our bones. Otherwise, we'll be walking around with broken bones all the time. They are important components of the cell membrane, which we'll see a little bit later. They act as phospholipids. There's a lot of hydrogen in lipids, a lot more than you will see with carbohydrates. And lipids have a different kind of shape. I like to think of them as having an E shape. They have this long, they have this chain called a glycerol. And then it's connected to usually 3 fatty acids. That gives the E part. Sometimes those fatty acids are saturated or unsaturated or polyunsaturated. But these are the fatty acids, and they can be very, very, very long chains. So if you see a picture that kind of looks like an E, it's probably a lipid. Next one, proteins, very important group. We talked about them when we did DNA. We just talked about them being with enzymes. Their building block is something called an amino acid. Amino acids have nitrogen in them. That's their kind of defining characteristic. They're also going to have the central carbon connected to 4 things, one of them being this amino group. So it's easy to identify a protein because it has nitrogen. So easy to identify. They function in building structure for our body, being antibodies, acting as enzymes. They help transport things across the cell membrane, which you talked about with the cell membrane. And they may connect together with peptide bonds. So we can have amino acids connect together, like we'll talk about with the DNA unit, which will be tomorrow, and they connect with a peptide bond. The last group of organic compounds are nucleic acids. Their building blocks are nucleotides. DNA and RNA are their primary examples, and we talked all about those with the DNA unit, which will be tomorrow, so I wouldn't really worry about that one right now. That's a lot, I know. We're going to give you as much information as we can.